Hello students, my name is Sumit Sagar Hota. I am a PMR PhD scholar IIT Palakkad. This is the week 1 of the live discussion section of the subject Turbulent Combustion Theory and Modeling by NPTEL. This is the week 1 of the live discussion section which covers lectures 1 to 5 by Professor Sumit sir. So this is the numerical problem solving section. In this class we will just solve some of the problems related to the preferred textbook and Introduction to Combustion Concepts and Application by Saturn, 3rd edition. Hmm. Hmm. So this is the first problem. We can just see a mixture is composed of the following number of moles of various species. Species are carbon monoxide, carbon dioxide, H2O, N2 and NO. And then the given number of moles are there, how many number of moles are available. Okay, so for carbon monoxide it's 0.095, for carbon dioxide it's 6, and H2O it's 7, N2 is 34, and NO is very less, it's 0.005. Determine the mole fraction of nitric oxide in the mixture. Okay, also express your results as a mole percentage and as parts per million, that is ppm. Okay, determine the molecular weight of the mixture, determine the mass fraction of each constituent. Okay, so these are the things we need to find out. Okay, okay, so let's start solving. Okay, so okay, so first we see what are the things given. So first of all we just see what are the species present here. Okay, so given is what? Okay, so okay, so given species. Okay, what are the species, what is the moles, what is the mass fraction, sorry, what is the mole fraction, and what is the mass fraction. Okay, So then what is the molecular weight of the each species? Okay. Okay. So for species CO, what is the moles given? That's what 0. Just substitute what are the moles given in the question. Okay. CO it's 0.095. CO2 it is 6. H2O it is 7. N2 it is 34. And NO it is 0.005. Okay. Okay. Now how I will calculate the chi and yi, that we just now see here. Okay. I will show you in the by solving the first bit. Okay. Accordingly, for all the species, the mole fraction and the mass fraction we just calculated. Going to calculate. Okay. Also, we know the molecular weight of the species. Okay. For carbon monoxide, it is 28.010. For carbon dioxide, it's 44.011. H2O it is 18.016, and N2 it's 28.013. NO it is 30.006. Okay. So first of all, you just need to know what is so how you will represent moles. Let it be Ni. Okay. So first of all, we just sum the total number of moles. Okay. If you just sum all these things, okay, all the values, we'll just get to know. Okay. It actually comes out to be what? 47. See, 3476 is 47, and 0.095 and 0.005 leads to 0.1. Okay, that's 47.1. Okay, so you are getting as what? 47.1. Okay, so so now I will solve the first bit, which is given to determine the mole fraction of nitric oxide. Okay, also express your results in mole percentage as a parts per million. That is in ppm we need to show. Okay. So the first bit, the chi is what? Ni by summation of Ni, that is the mole fraction of the particular species I divided by total number of moles available in the mixture. Okay. If it is now in this question, in the A bit, we need to find out for the what? NO. So N of NO divided by N of total. Okay. That is equal to what? 0.005 divided by 47.1. Okay. So if I can write down in term, and if you I just we solve it, we will get 106 into 10 to the power minus 6 kilomole per kilomole of mixture. Okay, so now what is the mole percentage? The mole percentage is equal to chi I into 100 is equal to 0.0106 percentage. Okay, what is the ppm? Chi I into 10 to the power 6 chi of NO into 10 to the power 6 equal to 106 bpm. Okay, so now in similarly for all the species in the similar manner we can just calculate the mole mole fraction of each species. Okay, okay, I already calculated the mole fraction of all the species and the values are 0.002, 0.127, 0.149, 0.722, and this we now calculated 106 10 to the power minus 6. Okay, summation of chi equal to what? 1. Okay, okay, so now we just calculated the what? Molecular weight of the mixture. The second bit is what? Determine the molecular weight of the mixture. Okay, since for finding the molecular weight of the mixture we need to find out the mole fraction of each constituent species. Okay, that's the reason why I already find out all the species mole fraction so that we can use in the what? Molecular weight of the mixture formula. Okay, so okay, the molecular weight of the mixture is equal to summation of chi I molecular weight of the I, chi of CO molecular weight of the CO, chi of CO2 molecular weight of the CO2, okay, plus chi of H2O molecular weight of the H2O plus chi of N2 molecular weight of the N2. plus chi of NO molecular weight of the NO. Okay, so now we have all these values. Okay, just we need to substitute and find out the molecular weight of the mixture. Okay. Okay. Okay, so what is the amount of what is the molecular weight of the mixture? Now I need to solve it. Kg per 28.6 kg per kilomole of mixture, right? So now the what is the next bit? We need to find out the what mass fraction of the each constituent species. Okay. Okay. Mass fraction of each constituent means we have to find out the Y of CO, CO, Y of CO2, H2O, N2 and NO. Okay. Okay. So what is the how we can actually find out the mass fraction in terms of mole fraction? So the formula is yi equal to chi I into molecular weight of the I divided by molecular weight of the mixture. Okay. So yeah, y of CO equal to 0.002. Okay, similarly we can find out the other values, okay, by using this formula. So this is the formula. So just now write down here all these values. Okay. So we just calculated all the bits of this question. Okay. Okay. So let's proceed to the next question. So the question is, okay, the question is, consider a gaseous mixture consisting of 5 kmol of H2 and 3 kmol of O2. Determine the H2 and O2 mole fraction, the molecular weight of the mixture, and the H2 and O2 mass fraction. Okay. 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 So So consider the gaseous mixture consisting 5 kilomole of H2 and 3 kilomole of O2. Determine the H2 and O2 mole fraction, the molecular weight of the mixture, and the H2 and O2 mass fraction. Okay. So what are the things given? 5 kilomole of H2 and 3 kilomole of O2. To consider the gaseous mixture, so determine the H2 and O2 mole fraction. Okay, that is chi of H2O2, then molecular weight of the mixture, then Y of H2 and Y of O2. Okay, so how we can calculate? Okay, so the in the question, since the moles are given, so the first choice to calculate is the what? Mole fraction. Okay. 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 So for this question, we just calculated the uh, mole fraction, okay, of the H2 and O2. Now we can just calculate the molecular weight of the mixture. Okay. So the molecular weight of the H2, and the molecular weight of the O2 is substituted. The mole fraction we already calculated. So now we can solve and calculate the molecular weight of the mixture. Okay. Okay, so next, what are the things we need to calculate? We need to calculate the uh, mass fraction of H2 and mass fraction of O2. Okay, so this three things, three things done. Next we calculate y of h2 and y of what. So the formula for mass fraction is I molecular rate of I divided by molecular rate of the mixture. Okay. This is basically for y of h2 I am calculating. Okay. Okay. So then what is y of O2? 1 minus y of h2. Okay. So this is the answer for y of h2, y of O2. Okay. Now we can go to the next question.
Hi, Sumit.
Yes. Is there any doubt?
Right now, till now, only 4 questions was solved. Huh?
No, actually, it's basically related to the books I actually am following. This is the book,
Hmm.
prescribed test book. This book I am following. So it's related
Okay.
to, okay. So this book I am
Hmm.
following. In that, I think 2 questions I just till now completed. Okay. It's actually
Hmm.
according to the books question number actually I am actually solving. Okay.
Okay.
Okay. So directly this is the
Oh.
exercise problems. Okay, in that book. Okay.
Oh. Okay. These are exercise problems from the. This is second chapter of the terms, right?
Yes, 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 yes. So
Thermochemistry.
yes, yes. So you are actually part of this course. Uh,
Yeah, yeah.
okay.
Part of it.
Okay. So just some of the problems actually in initial lectures actually I just follow because later on the advanced part actually certainly cannot follow. Some of the outside problems I will include and later on lectures. For now, I just whichever is required, I just follow from this book. Okay. So how much
Okay.
I can
Okay. Okay.
follow. So we can go to the next one. Consider a mixture of nitrogen and argon in which there are 3 times as many moles of N2 as there are moles of argon. Determine the mole fraction of N2 and argon, the molecular rate of the mixture, the mass fraction of N2 and argon, and molar concentration of N2 in kilomole per meter cube for a temperature of 500 Kelvin and a pressure of 250 kilopascal. Okay. So mm, mm, so first write down, just write down what are the things given. So number of moles of N2 is it's given the 3 times, in which there are 3 times as many moles as N2 as there in the moles of argon. So that means N of N2 is equal to 3 times of number of moles of argon. Okay, so the temperature given 500 Kelvin and the pressure given 250 kilopascal. Okay. So what we need to find out, to find chi of N2. Chi means the mass, sorry, mole fraction. Okay, then molecular weight of the mixture, so V I am representing like this, okay, with one dash line. Okay, so that's actually the molar concentration of N2 in kilomole per meter cube. Okay, so let's do the solution. So chi of N2 equal to number of moles of N2 divided by total number of moles of the total number of mole of the mixture. Okay. That is, just need to convert in terms of argon. Because here only N2 and AR is there. So this 3 by 4, which is 0.75. Okay. X of AR is equal to 1 minus chi of N2 is equal to 1 minus 0.5. So this is the, okay, so these are the values, and to, so that is the molecular rate of the mixture equal to summation of chi I into molecular rate of I is equal to, so now you know that N2 having a mole fraction of N2 is 0.75, mole fraction of argon is 0.25, molecular rate of each species we know. Now you just need to substitute and find out the molecular rate of the mixture. Okay, so we calculate, it comes out to be somewhat 30.99. Okay, now next we need to calculate. So these three things done. Now y of N2, that is the obviously the mass fractions we need to calculate now. So this is the relation how we can relate the mass fraction and mole fraction. To calculate it will come to comes out to be 0.678. Okay, and y of argon 1 minus y of N2. Okay, this is the answers. So now only I think one bit left, that is n of N2 by V. So okay, so for that we need to apply the ideal gas equation. Okay, that is PV equal to nRT. Okay, so since it's for N2, so just apply it for N2, the ideal gas equation. Okay, so P of N2 into V is equal to n of N2 Ru. Okay, so P of N2 is equal to chi of N2 into P. Okay, okay. So but here what is the pressure? The pressure will be the total pressure. Okay, these are the formulas you should remember while solving problems. Okay, so now what we will do, we'll just take the n of N2 by V. Okay, then it will be what? P of N2 divided by Ru into T. But what we know P of N2? Okay, it is your chi of N2 into T divided by Ru into T. Okay, so now we just need to substitute and find out the values. 0.75 to 500. Okay, so now if you solve it, comes out to be 0.0451 kilomole per meter cube. Okay, of N2. Okay, okay, so this is the answer for the last one. Now everything we covered here. Okay, for this question. Okay, so just go to the next question. So the question is, determine the standardized enthalpy in joule per kilometer kilomole of mixture of a mixture of CO2 and O2, where chi of CO2, that is the mole fraction of CO2 given 0.1, mole fraction of the O2 given 0.9 at a temperature of 400 Kelvin. Okay. So what we need? Standardized enthalpy in joule per kilomole of mixture of CO2 and O2. Okay. Okay. So okay. So the given is okay. So to find out the standardized enthalpy of the mixture, some assumptions we can take. Okay. So let's go to the solution. Okay. So for finding the standardized enthalpy, what is the standardized enthalpy? The standardized enthalpy is always a enthalpy is the enthalpy of formation plus the sensible enthalpy for a particular species. Okay. If the temperature is high, that is greater than 298 Kelvin, then it will be then there will be a sensible enthalpy, otherwise only enthalpy of formation of that particular species will be taken into consideration. Okay. So the enthalpy of the CO2 is H naught F means it's at 298 Kelvin. F means formation, CO2 for species CO2, delta H S per sensible enthalpy of CO2 since it is 400 Kelvin, which is higher than the 298 Kelvin. So these values are already available in appendix A, SR tons, third edition, intro to combustion book. Okay. So if you just see, just wait for a second. If you just see, it will be minus 393,546 plus 400, 40003. You can just solve it. You get minus 389,543 kilojoule per kilomole. Okay. Now the standardized enthalpy for O2, enthalpy of formation of O2, will be bar. Bar means for per mole basis or per kilomole basis. Okay. So since oxygen already available in the atmosphere, so that is for forming oxygen, we don't need any kind of enthalpy. Okay. So for all the naturally occurring substances like oxygen, nitrogen, okay, the sensible enthalpy is always 0. Okay. So yes. So now in the question they don't want the standardized enthalpy of the each substance, rather they ask the standardized enthalpy of the mixture. Okay. So for mixture there is a formula. AH of mixture is equal to summation of chi I Si CO2 H of CO2 bar plus O2 CO2 bar. Okay. Just now substitute all these values. So this is your answer. Okay. Here negative sign means we have to actually supply the energy to form that mixture. Okay. So go to the next question. This one liner questions are little tricky. So yeah, especially these kinds of question you can see in some uh, maybe some UPSC or some examinations, you can see this kind of one-liner. Okay, so determine the molecular weight of the of a stoichiometric methane air mixture. Okay, in this question nothing given. Okay, only one stoichiometric methane mixture is there. Okay, and what we need to find out, the molecular weight of the mixture. Okay. Okay. So this is stoichiometric mixture of methane. To find out the molecular weight of the mixture, assumption, we are taking air having 21% of oxygen and 79% of N2, because this percentage may vary slightly. Okay, so that's the reason we just taking it 21 and 79. Now I am actually writing the formula for a general hydrocarbon fuel. Okay, then we'll just write down for the methane. Okay. Into okay. Now if in place of CXHY, if it will be your CH4, then X will be 1, this is 1, okay, X1, and Y equal to 4. And the formula for A is always, so remember, X plus Y by 4. Okay. If you don't want to remember, you just need to balance all the equations. Okay. So by balancing all these things, when done, this formula only came. Okay. If you don't want to do the balance, you can directly write down the equation for CH4, then just balance left hand and right hand side. Okay. So this is the CH1 plus 4 by 4 is equal to 2. Okay. Now just, so here we have actually X, we have Y, and we have A. So now we just need to substitute in this above equation. to find out the general equation for CH4 combustion, methane combustion. Okay. Okay. So yes. So now for finding the molecular weight of the mixture, we need two things. First, the mole fraction, and the second is the molecular weight of the E species. Molecular weight of the species you already know. Only you just need to find out the mole fraction of the E species. And for finding mole fraction, we need number of moles of the E species and number of moles of the mixture, or total number of moles. Okay. So if you see, the number of moles of CH4 comes out to be 1. Okay. Since CH4, it's only 1 is there. Okay. O2 it will be 2, N2 it will be 7.52. Okay. The total number of moles CH4 N of N2 N of O2. Okay, the total number of moles is 10.52. So now we have to just find out the mole fraction. Chi of CH4 is equal to N of CH4 by N total equal to 1 by now we have the mole fraction of the E species CH4, O2 and N2. Now we need to find out the molecular weight of the mixture. Okay, so now we just need to solve and find out the molecular weight of the mixture. Okay, so this is the answer. Okay. So in the similar way, you can calculate different species molecular weight like methane, ethane. Okay, then propane. Okay, if you remember it, then it will be easy in the MCQ questions. Okay, okay. So just go to the next question. Determine the stoichiometric. So let's solve the next question. Okay, so so for this question, so what are the things given? So determine the stoichiometric air fuel ratio in mass basis for propane. Okay. Okay. So the assumption. Air containing 21% oxygen, 79% N2 in volume basis. Okay. Okay. So for C3H8, what is X? X equal to 3 and H. For H, what is the Y? Y equal to 8. Okay. For 5, 1. Okay. Okay. So now if it is not in stoichiometric, then the formula for A reduces to A is equal to X plus Y by 4 divided by 5. But here 3 plus 8 by 4 divided by 1 is equal to 5. Okay, A equal to 5, right? Okay. So now we need what? What we need to find out? The stoichiometric air fuel ratio in mass basis. Okay. So first we need to find out the air fuel ratio in terms of what? The molar basis, right? Okay. Okay. So what is the so how we can now convert the air fuel ratio from molar basis to the air fuel ratio in the mass basis? Okay, it's very simple. We need to just multiply the ratio of the molecular weight of the air to the molecular weight of the fuel to the air fuel ratio of the molar. Okay. Okay. So four point 7 6 into 5, 28.85 44.096. Okay, so now when you solve it, you can just get the answer of airfoil ratio per mass basis. Okay, so let's move on to the next question. The propane burns in a pre-mixed flame at an air-fuel ratio of 18:1. Determine the equivalence ratio phi. Okay. Okay, so let's write down. Okay, so the propane burns in a pre-mixed flame at an air-fuel ratio by mass 18:1. Determine the equivalence ratio phi. Okay, we need to find out. We need to find out what the phi. Okay. Okay, what are the assumptions? Okay, so now we just find out the phi because sorry, we just find out the a. Okay, So since for propane x is equal to 3, yeah, so that's the whole idea. So now we just need to find out the stoichiometric airfoil ratio. Since in the question actually airfoil ratio given, we need to just find out what the stoichiometric airfoil ratio. Okay. It means you okay. Yeah. So what is a stoichiometric airfoil ratio? Okay. So this is your 4.76 times A molecular rate of air, molecular weight of fuel. Okay. 4.76 times 28.85. Okay. To solve it, we will get air fuel ratio 15.6. Okay. Okay. So now we just need to find out the phi. Okay. So phi. Okay. By solving, we'll get the phi as 0.87. Okay, and it's less than 1. Okay, that means a lean mixture. Okay, lean fuel mixture. Okay. Okay, so let's do the next one. For an equivalence ratio of 0.6, 5 equal to 0.6, determine the associated air-fuel ratio in mass basis for methane, propane, decane. Okay. Okay. So okay. So let's write down what are the things given. Phi equal to 0.6 given. So we need to find out the airflow ratio for the methane, propane, and decane. Okay. Assumptions: air containing 79% N2 and 21% O2. Okay. Okay, let's start solution. For methane, okay, x equal to 1, y equal to 4. Molecular weight of the CH4 16.043 kg per kilomole. A is equal to x plus y by 4 divided by 5, 1 plus 4 by 4 divided by 0.6, which is 3.33. Okay. So what is the formula for airflow ratio? Okay. So just solve it. Okay. This is for methane I calculated. (28.5 kg of air divided by kg of methane). Okay. 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 So next forward propane. Okay, so similarly I found out for the also decant C10H22. Okay, the A value is what? 25.83. Okay. Okay. So what you get to know here? Okay. So the relation is air fuel ratio of C10H22 less than air fuel ratio C3H8 and air fuel ratio of CH4. Okay. Okay. This is what you get to know. Okay. Okay, let's go to the next one. Using results of problem 12, determine the stoichiometric air fuel ratio of methanol CH3OH. Compare results with the stoichiometric ratio of methane CH4. What implication does this comparison have? Okay, so let's write down what are the things given. So air fuel ratio. Okay, and CH4, right? Okay, so these things we need to calculate. Okay, what is the things given for CH3OH? What is X? X1, Y 4, Z is for what? Oxygen content, okay, which is 1. Okay, so now what is the fuel ratio? MCH3OH. Mm. 4.76. Okay, which is 4.76. 1 plus 4 by 4 minus 1 by 2. 28.85 divided by 32 comes out to be 6.4. Okay, similarly for CH4, X is equal to 1, Y4, Z0. Okay, equal to 17.2. Okay, so now uh, what is the ratio of their full ratio? Okay, for comparison purposes, CH3OH. Therefore, 37.2% of air fuel ratio on mass basis of CH4 is same as air fuel ratio of CH3OH. Okay, so this is the conclusion we can take away. Okay, okay, thank you very much for attending the section. If you're watching the recording one, thank you very much. If you have any doubt, you can write down in the comment section in my YouTube channel, which is Sumit Sagar Hota. It's my name only. Okay, you can type and you can ask any doubts. Okay, regarding any doubts regarding the say assignments, you can ask in the question and answer forum. Okay, thank you very much. Good night. See you next week. Have a nice day.